energy, ability, capacity to do work. And
Yes,
there are
ma'am.
types of energy, right?
Yes, ma'am.
For sure na,
Moralis po siya, okay?
for sure na
Moralita.
namoy energy nga nahibawan, like klaseng types of energy. As mentioned in here, kinetic energy, it's the energy that is possessed by a body by virtue of its motion. Okay, if an object is in motion, then that object has a kinetic energy. Specifically, um, okay, kung naa siya speed v, and of course the object has its mass m. And we have also different types of energy. We have ang pinaka-known or the commonly used kinetic energy is the translational kinetic energy, which is given by 1/2 mv squared. And there are types, depende class, na pamampoy laing motion, types of motion. Kung translational, then we have translational motion. We have also rotational motion. So depende na dahil class ang mga types of energies, depende sa motion. And also, an important result regarding the relationship within the work and the kinetic energy is the work given by W sub R, or the work done by a resultant external force acting on a body equal to the change in its kinetic energy. So work done equals change or delta E, or delta kinetic energy. And we have also the type of energy, which is the gravitational potential energy, which is the energy possessed by a body by virtue of its position. So kung position na gani ang gihisgutan class, let's say a body that is at rest, but sa pag at rest na siya sa taas or elevated siya, then it has a gravitational potential energy. So again, gravitational because there is a gravitational pull. Gitawag na po na siya potential because it has the potential para ma-convert to a different type of energy. And so the potential energy, gravitational potential energy is given by the equation U ni siya class ang kuanan ng gravitational symbol equals mgh with elevation h. And the work done by the gravitational force acting on the body is given by mg, so that is constant mg times h2 minus h1. Again, m is mass and g is the 9.8 meters per second squared. As you can see, so work done by the gravitational force, it only depends on the elevation, h1 and h2. That means to say that the gravitational force is a non-conservative force, and it is the work done is path independent. So it doesn't matter kung unsa ang giagian niyang sa iyahang motion pas nagtutuyok ba na siya paingon sa iyang last final position, gaslant na siya as long as we have the final position and initial na position h1 h2 along the vertical, so we can find that the work done by the gravitational force is path independent and only depends on the initial and final positions or elevations. And the sum of the kinetic energy and potential energy is called the mechanical energy. Okay? Kapag potential na ni class of kinetic, mechanical lagi na siya. Okay? And if a body that moves from point 1 to point 2, then we have the change in kinetic energy, which is equal to the work done by the external forces, except by the gravitational force acting on the body. And if the only external force acting on the body is the gravitational force, then the energy at position 1, that is equal to its mechanical energy 1 equals the mechanical energy at position 2. So we can say that the total mechanical energy of the body is said to be conserved. So conserved gani class, it means constant. Okay, at point 1, point 2 equal, that means conserve ang total mechanical energy, constant, and it won't change. Total, take note of the total. Bala pang mag-change ang gravitational potential energy, but some of its gravitational potential energy will be converted to kinetic. So mo nang ang sum equal gihapon at any points or elevation of the body. And then, here's the, I'll show you kuan class. The video, so I'll be sharing a video para sa reference or lecture video sa about sa activity. Okay. Kita na?
Yes, ma'am.
Work and energy. Work and energy.
So again, grab your pens and papers to record everything, especially the values needed for the calculations. So it starts at 5, 4, 3, 2. Okay.
A physics laboratory activity. The energy possessed by a body by virtue of its motion is called kinetic energy. If a body has a mass m and a speed v, then its translational kinetic energy E sub k is equal to 1 half mv squared. An important result regarding work and kinetic energy is that the work W sub t of the resultant external force on a body is equal to the change in its kinetic energy. W sub t is equal to ek2 minus ek1, which is equal to delta E sub k. Moreover, the energy possessed by a body by virtue of its position is called gravitational potential energy. A body of mass m at a height h above a reference level has a gravitational potential energy of mgh with respect to that level. If a body at elevation h sub 1 is moved to elevation h sub 2 along any path, then the work of the gravitational force is W grav is equal to mg h sub 2 minus h sub 1. This path-independent work depends only on the body's initial and final elevations. The sum of the kinetic energy and potential energy of a body is called its total mechanical energy, E sub m. If a body moves from point 1 to point 2, then W prime is equal to delta E sub m, where W prime is the sum of the works done by external forces except the gravitational force acting on the body. If the only external force acting on the body is a gravitational force, then EM1 is equal to EM2. Under this condition, the total mechanical energy of the body is said to be conserved. In this activity, the objective is to observe and verify the principle of conservation of energy. We will be using the following materials. First is a curved track, a marble, meter stick, bond paper, stopwatch, platform balance, PHET interactive simulation for energy. The first part of the experiment is the usage of the curved track. First, we set up the curved track on top of a table whose height is less than 1 meter. As you can see in the figure, we have two heights to measure. The first one is y sub b, which is the height from the lower part of the curved track where the marble exits up to the ground, and y sub a is the height from the top of the curved track to the ground. And as you can see, our setup is divided into three stations. We have part A, which is at the top of the curved track, part B, which is at the lower portion of the curved track where the marble exits, and part C, this is the part where the marble hits the ground. In the figure, y sub b is the elevation from the lower portion of the curved track where the marble exits. Then we record the height of the curved track, which is the upper to the lower portion, and denote as h. And then we solve for the total height of the curved track with respect to the ground, which is y sub a. Again, y sub a is equal to h plus y sub b. Here we set the curved track on the edge of a table and we practice how to use it. The curved track is used by releasing a marble from point A, and upon reaching point B, it has a horizontal velocity, and we note the approximate location of point C, or the point where the marble strikes the floor. Now we place a carbon paper with bond paper underneath on the landing position C. We do 3 trials of the experiment to get 3 experimental values of the horizontal distance that the marble covers upon hitting the floor, or the part which is part C. We record the horizontal distances measured in trials 1, 2, 3 as x of 1, x of 2, and x of 3 respectively. The theoretical time of flight is calculated by using the equation y sub b is equal to 1/2 gt squared. And using the digital platform balance, the mass of the marble is found to be approximately 5.06 grams. Now, having obtained all this data, we are now ready to answer Part A of the activity worksheets. For Part B, we will be using the PHY simulator. As Step 1, in the PHY simulator, given by the link below, we set the magnitude of the friction force somewhere in the middle of the bar, the gravity to 9.8 meters per second square, and the mass with the same as your own. Look at the figure at the side. This is an example. For me, friction is set at the middle of the bar, gravity is set to 9.8 meters per second square, and the mass is set to my mass, which is 58 kilograms. In step 2, we set the height of the track to 6 meters at both sides. To check that it is 6 meters, there is also a tool in the simulator which measures the vertical height. Step 3. Now the skater is ready to roll. Measure the decline in the height reached by the skater in the track and the time interval. In taking the time interval, you might need a partner to do this. To measure accurately, set the motion to slow. In step 4, you graph the decline in the potential energy PE of the skater versus time interval in your activity worksheets. The potential energy is obtained using the formula mgh, where h is the height in meters, m is the mass of your skater, which is just your mass, and g is the acceleration due to gravity. In step 5, we do steps 1 to 4 again, but with the friction set to a maximum. If you look at the figure at the side, this is an example for my experiment. Friction is set to the maximum. As you can see, that the bar is moved to the right. Gravity is still 9.8 meters per second square, and mass is still 58 kilograms. This is a screenshot of my simulation. In the simulation, a minimum of 5 data points should be taken to have a graph. If the data points are greater than 5, then it would be great because the graph would be much accurate. This ends our experiment in work and energy. All the data that you need is already at hand, and you may now answer the questions found in your worksheets. Thank you very much for watching this video.
Okay. So, nasabtan na ninyo ang activity. I mean, ang procedure in finding those values na kay actually class agabot sa exam, it is not about dun sa activity sheet lang or kanang makita nimo nga calculations and yung parang ani discussion, but apilon po tong mga processes sa procedure on procedure about sa activity and sa on pag-perform ang activity. Okay. Nakuha ninyo itong mga values, the height, YA and YB.
Kuan naman, katulong mga trial. Katong paghulog na sa Jolene.
Okay. Hulog.
Katura ako ng record.
Ani. Okay, so in ano na siya, no? Sa procedure, you have the curve tract, and we have three locations, point A, point B, and point C. So, in this activity, supposedly, kung i-perform na siya, muna siya, no? Butang ang marble at point A, and then let it, fall from B to C, ganon. And then place the carbon at point C to measure the X. And this X is measured from the edge of the table. And then you measure, di ba, the YA and YB, and it is given in the video. We have YA and YB. And then the data, fill in the table using the given values from the video. Sa ganito class ang elevation YA and YB, diri ibutang, as well as the horizontal distance, X, and the time T, theoretical. Nabagiin diri nga calculate the time T. But this is from the katong calculated time na di ba naputi calculated time? Ay no, calculated measured time sa video. I guess mo na siya diri as a trials 1 to 3 and then get the average. Average T and average X. And then take note also sa mass of the marble, pila to nakabutang nga grams, and also dapat naka-SI, kailan ba i-SI? I guess it's okay, naka-cm raman po ng elevation, as long as ang inyong calculation, especially let's say sa number 2, find the equation of the velocity, find the velocity or the speed at point B. It should be tama nga unit, either meters per second, centimeters per second. So it depends on saying asa mo masiyang. And then, given na diri class on sa ang inyong gamitan ng equation to find the VB, and also in calculations, use the average values. And then compute the potential energy. Okay, the gravitational potential energy, which is U equals mgh, and then translational kinetic energy, which is 1/2 mv squared, na ang equation sa taas, and then ang total is i-add lang ang potential of ang kinetic. So you have total mechanical energy sa last column. And then you can find here na discrepancy sa values between A and B. So explain this, why is the total mechanical energy of the marble from B to C conserved? I know B to C is conserved, but from A to B, it is not conserved. You explain that one, why? And then compute the work done by the friction between the points A and B. And then we have also the second part, the simulation. So, ang saratong procedure dito nakabutang class, o dinhi, I guess, kasabot na mo sa paggamit sa FET, kaya hindi pa nag-FET pod mo sa free fall. So, para masabtan ninyo class, I'll share somehow kanang marag calculation gani in solving, finding velocities, speeds at any points using energy conservation. Wait lang ha. Ako i-share. Okay. So, di ba nag-anak na to class ang tawag ani? Ang track. Okay. So, mali. Straight na siya. But straight. B, and then, ano siya, hulog siya at point C. So, the potential energy is given by U equals mgh. Kinetic energy is 1/2 mv squared. And then mechanical equals u plus k. So at point A, we have using conservation of energy. A and B is not conserved, okay, because there is something na nagbabag sa motion sa acceleration, nagbabag sa motion sa marble. And actually, it is mentioned na dito given na we have the work done by friction or kamo nalay kuan class A. I-rephrase ninyo ang statement ng nganong dili conserve ang mechanical energy because of friction, okay? Na i-state ninyo, i-rephrase ninyo ang answer para lang malahi-lahi. Basta ang answer dito, tungod na siya sa friction. It's up to you saan ninyo pag-rephrase or maybe there's a work done on the friction or saan ninyo na paglarlar. So, point A, between B and C, since the air resistance is negligible, we have UB plus K sub B using the principle of energy of conservation of energy. The total mechanical energy at point B and point C are equal. So therefore, you have UC plus K sub C, which is equal to UB plus KB. And then, we have mg. Ang atong height at point B is given by YB bato class. If YB, then tama na. And then we have 1/2 m. Ang iyang velocity at point B. And then we have mg y at point C. And then 1/2 mv c squared. So, if the total mechanical energy is conserved, which is conserved man po between B and C, kay neglect lang nato ang air resistance, we can find other quantities here. Kung naabay gipangita sa procedure, kung naabay gipangita sa activity, let's say find B sub C, you can use this equation to find the B sub C, or unsa pa din ang pwede makita, but I guess B sub C lang. Pero wala man nato ipangita sa activity. And V sub B, given na kaganihang ang V sub B is given by x over t. So this one is from the equation lang, kinematic equation, which is x equals x naught plus b naught xt. It means we have x equals x naught is 0. Kung itong iset, this one is 0. Okay, so therefore we have x. So we have x plus ang v naught x. Okay, since our marble, pag abot na sa point B, has a horizontal, will undergo horizontal projectile motion, therefore its velocity is horizontal lang along x, so na lang kay x component. So therefore you have v sub b times t. Mo na si v sub b equals x over t na siya. So mo na yung substitute din if ever lang pangitaon si v sub c. Okay? And then, why is there, or the total mechanical energy is not conserved? Because there is a work done by friction, okay, between A and B. So we have potential energy plus kinetic energy at point A minus the work done by friction equals, because energy man gyapon ang work, but this is the work done by the frictional force. Kapag naagani work class, meaning pag na-force, it depends kung sa ka-object nag-move, then naa siya yung work done. Ang work has a formula which is equal to force times distance, di ba? So kung na-force, then na-displace pod ang imuhang object, that means na ay work done ang force. Okay? So in this case, si marble between A and B, kaya nag-movement siya between A and B, therefore, si frictional force has work done, okay, sa marble. And negative because, okay, kapag ang force is on the same direction, if the two are in the same direction, then we have positive work done. However, kapag ang force is on the opposite direction with the displacement, the work done is negative. So si frictional force is always an opposing force. Always yun na siya mo-oppose sa motion sa object. Like say, kung paingon sa left ng isa ka object, then si frictional force, paingon na siya sa left. So yung ana siya, always na siya nga ma-oppose din sa motion. So therefore, we have negative work done of the friction. And this sum of energy equals, since the principle, using the principle of conservation of energy, we have UB plus KB. Pero wala na friction between B and C. Kung may air resistance din na, pero diri it is negligible. And find naakay mg YB, YA, napod kay M1 half pala, 1 half MVB squared minus work done by friction equals mg YB plus 1 half MVB squared. Ay, ano na B man eh? A din siya. Okay. Given ang VB, nakuha na ninyo ang VB sa kaninga equation, and then you have also the YA, okay? YB na apod, ang M na siya, pila to gramo, and then 9.8 meters per second squared nga acceleration due to the gravity G. And then, how about your V sub A? This V sub A, so this term will become 0 because V sub A at this point is 0 because the marble starts from rest. So therefore, this term will become 0. And you will get finally the work done by friction. So yan na siya paggamit class sa conservation of energy, finding quantities using the principle of conservation of energy. Ang nakalindot ani class, for example, sa V sub C, panigin sa V sub C, pwede nato ni siya makuha gamit ang kinematic equations, but pinakadali gamiton ng principle of conservation of energy to find the velocity of the marble at point C. Speed lang di ay magnitude. Okay? So, I will share to you sa classroom. Akong i-share ang activity as well as the video. Okay, basta nalalapot nyo nakuha, no? Ang video ba sa inyo magpilit-pilit? Kaya nga na ako mabantayan sa gara pag-zoom. Sa akong
Dahil tayo naman magpilit-pilit mo.
Magpilit-pilit siya, no? Delay, na delay. Makabantay gid ko na. Budget ng class, kanang 18. Ay, nagduble diri. Kasi na-add diri. Di ba 14 raman mo sa klase? Ay, 20 di ay. Namagod ko isa ka section class na 14 ras po mo. Oh. Yes, Andre.
Ma'am, nating G classroom, ma'am? Or magpabuhat tayo po lang yun?
Saan na, Ana? And paglantaw na ako, wait na ako lang ikwan din. Nagkanti ko lab class mo itong maglibog ko na Ana or wala pa. Wait na ka, ako i-check.
Wala pa
H78. Yeah, wala pa. Since kamo ang last nga laboratory na ko karon nga week, so kamo ang last mabuhatan og classroom. Okay, magbuhat ako later. Then akong i-post na ang activity sheet as well as the video for your reference. And message lang ko sa kuan. By the way, so Mabel, ikaw ba to Mabel nagkuan message sa GC? Wala ko bantay adto ay sina-open na ako ba niya wala ko ka-reply sa pag-busy. Kailangan pa ninyo. Yes?
Dili ako ay Nag-message lang din ako, ma'am.
Si
Mabel.
Christine pala, si Christine. Kailangan pa ninyo kailangan pa ninyo i-change ang activity 1. Napa may gusto i-change adto. So mani pag wala. Exit full screen. Oy. Ano yun mawala? Share na ko daw balik, be. Activity 1 lang or appeal ko na activity 2. Pero wala pa man ako nakuha ng activity 2 na close. O sige lang class na may classroom, mas ayun na ang sa classroom. Share. Wait. Ay, hinay kayong signal. Loading. By the way, kasi wala. Ay, kung 20 mo kabuok na ay tulo na wala. Kailan mo inyong groupmates. Tama yun ay. Sa akuara ngala ng nadinhi. H78. Amot na ka-class no, kung mulahin na yung instructor, kung magpadayon pa ba magamit sa classroom, tungod kay ang naibawaan na ko nga na-access sa Google Classroom kay Akura.
Dagan, ma'am.
Unsa?
Depende sa dagan.
Depende sa
Dagan sa panahon.
agan. Okay. Weird mong god. Pwede na ako siya isulod sa pwede na tayo padayan ang kuan classroom. Pero na ako ang teacher. Wala siya i-control. Kung siya estudyante, kung i-add na ako siya sa classroom. Weird lang. Mura nin siya classmate. Punta, maka-access sila og classroom kay katong naging istorya sa ubang lecturer na wala sila isla kabuhat og classroom kay wala sila kanang katuganing pag once mo sulod ka classroom kay naman na siya plus nga button and then it means join class or create class. Kung teacher ka din pwede ka mag-create. Pero kung wala kay create kay automatic student ka, which is wala sila wala sila access ba, so di sila ka-create og classroom. Mao ang problema sa ubang teachers. Pero ako na ako'y access na ako na explore lang din. Ganahan ako. Di mo ko sure sa kuan sa itsura niya. Mao ako makita nga screen but wala ko kabalon sa makita ninyo and then naman to isa pa estudyante na ako nagkuhan. Pagkita nga ingana daw ilang makita sa ilaha. Pwede din mo mag-submit no. Mag-submit sa pero na ay part, di ba, sa upper right and then mark as done. Okay. Nakita na ko inyo ang list. Pwede na ako ma-share balik ni karon taod-taod ang folder sa first activity. Wala pa po na ako na-close ang second activity. Kaya naman po deadline which is today. And ang sa next activity, activity 3 again, Google Classroom na ta class. Dito na mo mag-submit. Okay?
Okay, ma'am.
Yes, ma'am.
So, activity 3, ma'am, Google Classroom na may mag-pass.
Yes, Andre.
Okay po, ma'am. Thank you, ma'am.
Send
Yes,
lang
ma'am.
kong code. Send lang kong code, ha? Di na ko mag-invite nga kanang isa-isa mag-invite. Code lang.
Sige po, ma'am.
And then sa absent, kamo na yung mag-ingon ni class. O na itulong nga wala. Asa ka to. So, naman ako class kasi na yung mga, let's say, brown out or panahon ka lang kasi ulan, pakasayod, unsa sa ilaha.